Then the other question is now you're putting more things in airspace, and people need to know where everything is. There are no roads defined up there. There's no, right? You got to make sure somebody's keeping track where everything is flying. Air traffic control is a big deal. There's a lot of problems yet to be solved. It's a lot of opportunity there for people to make some money in the future of figuring out how these industries will mature. But the tolerance of non-success is far less today in an industry like this.
Hello and welcome to another episode of the Break Free podcast, where we're interviewing great leaders that are making the world a better place through the companies they lead. Today we have with us Ron Felix. Welcome to the show.
Glad to be here. This is an exciting opportunity for me. Let's roll.
Ron, it's been a long time since I've been able, I wanted to do this podcast with you. So let's go right into it. For the audience, can you give me your full name? Where do you live and what do you do for a living?
Okay. So I'm Ron Felix. We could just leave it there. I'm the CEO, president of Moeller Aerospace. Moeller is a 425 plus person business. We do somewhere north of 175 million a year in annualized revenue. And our primary purpose is components for gas turbine engines, mostly stuff that flies, commercial aircraft engines, some military fighter engines, transports. We do some land-based componentry for turbines, for energy supply, and we dabble a little bit in space for pumps for liquid rocket engines, the big ones that take up the space shuttle and stuff like that. It's a great organization. We're part of a very large supply chain in both commercial and commercial aerospace and defense, and our people are very proud of what they do.
This podcast is brought to you by ISU Corp. Are you having trouble with your software projects? Is there a project that's taking too long or a technology you can't handle? We can help. We are ISU Corp, experts in custom software since 2005. With almost 20 years of experience, we can solve any technical problem from new businesses to satellite software. We've done it all. Let us turn your ideas into reality. Learn more about how we can help by visiting us at www.isucorp.ca. Your solution starts here.
That's beautiful. So when they're creating the engines, they certainly call you to have that part of the engine created, right?
We don't do the design. We're build to print. So the three big OEMs are Pratt & Whitney, General Electric, Rolls-Royce. They'll design their turbines and all the components in the engine. We have two facilities. One is general componentry. Sorry if that's interfering with something here. One of them is general componentry, rotating parts, cases, bearing housings. But our specialty is high nickel content alloy, high and low pressure turbine blades, vanes, and shroud segments. So everything in the very hot section of the engine. A lot of the components that we produce, 4 to 3 OEMs, operate anywhere between 3,200 degrees Fahrenheit and 900 degrees Fahrenheit. So it's quite a spectrum. Very high precision. We use very elaborate investment castings as our input stock. And it's a skill and a niche to be able to maintain the tolerances and put in the technology that the OEMs require.
That's fascinating. And when I look at the aviation industry, and if you think that how much does an average commercial plane last? Like, what is the lifetime of an average commercial plane?
A plane or the engine?
Well, let's look at the engine first, because I guess they can overhaul it, right?
So an engine serial number should last somewhere between 25 and 40 years.
Right.
Now, you might change out a significant amount of those components over the 25 to 40 years, but on average, an engine serial number will fly 25 to 40 years. I don't think planes are too far off of that. I'm not sure they quite hit the 40, but 25 to 35 years is probably a good mark. The good thing about this business is it's highly regulated, very well engineered, different different spans of time and or cycles. Cycles is how many times planes go up and down or engines throttle up and throttle down, and everything's fairly regulated. And there's different series. After so many years, you do this. After so many years, you do that. After 7 years, you take them in for heavy checks. It's an incredible machine that incredibly reliable, and they'll fly for an awfully long time.
That's beautiful. Now, what I find fascinating is that to have such a large business like yours supporting an industry that the products they produce are longer term, right? So, like, how many planes do they produce a year in order to support this industry?
New commercial airplanes. Let's see. I should know this off the top of my head. We're doing roughly, I think Airbus is doing somewhere around 700 plus planes a year, and I think Boeing's somewhere in the 350, 400 these days. Boeing's has a bit of a challenge. But the bigger thing about this industry that people don't realize is it's sold out for the next decade.
Sold out. Wow.
Sold out. No, now everybody's trying to increase output rates. Everybody wants more faster.
Right.
But if you're coming to buy a new airplane or even a new engine, you're going to wait 3, 4, 5, 6, 7 years, depending on the model right now.
That's incredible. So you're in a great business then.
It's a business that has its ups and its downs. Okay. So the good is anytime I start a new fiscal year, I pretty much can tell you what the year is going to be. It's an execution problem then, right? I'm going to make so many parts based off of a build plan at any of the OEMs, or based off of a overhaul repair plan for spare parts that the OEMs are feeding into us. So it's execution. That's the good news. The bad news is if you're owned by people who, want a task, it's hard to change the year. If I'm going into a year and I have $175 million of volume, because of the lead times on our products, which can be anywhere between 30 weeks and 90 weeks, you're almost spanning 2 years.
Right.
It's hard to change. It's not a business that you could rapidly grow in, right? I can't say, hey, go to my sales team. There's $175 million of sales out there this year. I really want 195 or 250. Go make it happen by discounting my product 20% and drive volume. The normal, supply demand price curves don't necessarily work as directly in this business on a short-term basis. Over a long-term horizon, they're just as valid. So it's a wonderful business. It's very steady unless there's some macro geopolitical event to disrupt something. It's filled with high craftsmen, very talented people who understand their job is to keep anywhere between one very important military pilot flying a mission up in the air or 350 people going on vacation in Orlando to see the mouse up in the air. It comes with the same technology, the same reverence, and the same dedication to making sure the systems work right.
Well, and imagine, Ron, like those engines are vital for the safety of all the passengers and all the pilots, right?
Look, you're not only worrying about the passengers, you're worrying about the crew, you're worrying about the people on the ground underneath the planes that fly every day. And I don't think people understand how many actual flights are in the air on the average day. I think the last time I saw a number was something like 35,000 flights around the world on the average day.
35,000.
35,000. Don't hold me to the number, but that's somewhere the last number I saw. If you go on, there's lots of great websites. If you ever are bored someday, Dave, and look at Flight Tracker, it will show you all the planes in the air at any one point in time over the globe, particularly over the continental U.S. It becomes just a giant swath of color. It is amazing to see how many planes are in the air in the average day. Here is a data point that I did just get recently, and I'll throw it back at you just to understand the business a little bit. What do you think % of the world's population is flown in an airplane?
I think I'm going to cheat because I think I saw that last year. I think it was 40%.
10.
How many?
10%.
Only 10%?
Only 10% of the world's population have ever flown at least once in an airplane.
But didn't they have the numbers that 4 billion people flies in 1 year? I think we can say people fly more than 4.
No, I don't know where that data came from. I know because I was just at a few conferences where the data point came out. 10% of the world, 90% of the people on this earth have never flown in an airplane yet.
90. Wow.
And the whole earth, you got to remember.
Well,
Right?
it is still a privilege, isn't it? We take it for granted, but it's a privilege.
You and I take it for granted. You live in Europe, you live in North America, even South America, but there's certain populations of the world that are just basic economics. So imagine the growth that's in front of us just to get it to 20% or 30%.
Wow.
Now, there becomes significant other challenges, right? People worry about environmental concerns. People worry about, can you have that many airplanes in the sky at one time? Do you have the flight control systems? Do you have enough of pilots and flight attendants and mechanics and everybody who has to service the planes? But it is an industry that we take for granted that's still catering to a very small population of the world.
10%. I would imagine it was a lot bigger.
No.
Yeah, I guess you get, it's because the way, like, I've been flying most of my adult life for business, right? I run a software consulting firm, and that takes me into planes everywhere. And the more you do it, the more normal it becomes. I remember, back when I was starting the company back in 2005 to 2009, I was doing a lot of business with Argentina, and I was flying every 2 weeks to Argentina. So whenever I stopped in Chile, which was the layover, the people at the restaurant knew my name. They were like, "Oh, hey, David, you want the same, the same as last time?" Like if it was your local coffee shop.
So here's a question. Did you stay loyal to one extra airline or to one particular airline?
I did. Yes, I was doing Air Canada because, well, at the beginning they had the red eye, so it was fantastic. And it was a single flight. Then they changed it to have a layover in Chile, but it was a very pleasant flight. Back then it was great.
So, like we said, it's a great industry. Great. And there's great people in it, very dedicated people. People who understand, they might not understand all the technology, but they certainly understand the technology that their piece that they have to deal with. Look, I have over 425 people today making parts. 3/4 of that is labor on our manufacturing floors, whether it be high-skilled machinists, inspectors, welders, other special processes. You go out on the floor and you talk to our folks, they will beam with pride of the stuff that they do could deliver a mission so critical for either social network, commercial, or military for missions of need. And it's something people put their chest out on and say, look what we do.
Well, if you think about it, talking about the military component, I mean, the military component allows the commercial component to operate freely because when you have a defense system, look what's just going on in the world, right? Like the Air Force now is more important than ever, right?
So not to go into details, but think about just what happened over the last 48 hours in our world. A series of aircraft took off from Missouri, flew 30 hours, performed the mission, and safely landed in Missouri and never touched ground.
Incredible.
It's an amazing machine, and it's an amazing support network to be able to pull off a mission of that nature.
Yeah, it's so impressive. What do you see? How do you see the future of engines? Like, is there room to innovate? Because I see how these planes fly nowadays. It's like, how can you make it better?
So this is an interesting subject for me to ask. So I started 40 years ago at one of the OEMs, Pratt Whitney, and excellent company to work for. All three of them are Pratt, Rolls, and GE, and they're smaller gas turbine companies that service the industry as well. I have watched us push the physics to what we know as current physics. Each one is in computers and 3D, 3D dynamics, computational dynamics, all the stuff that has happened over our lifetime have maximized these engines. You could scale them a little, but I think we're getting to the point where the physics are getting pretty mature. That's Ron's opinion.
Right.
Is there alternate things to do a little differently? You know, can you run on hydrogen, alternate fuels? Could you go back to, but in a quieter mode, propellers on the outside of the engine casings again? Right. In the old days, there is certain people who believe you could have quiet propeller thrust in the industry. I think it's matured out to the point where it's leveling off. Now, that's on the commercial side. The military side, you have hypersonics and the blending between a commercial engine or a current military engine and some kind of rocket propulsion. That's a whole different world. That still has room to grow. That still has physics to resolve. That still has material science to push. But I think for what we see commercially, we're probably at the limits. All right. We'll get a little more efficient. We'll gain a little more extra. You know, in the commercial airline, what you really care about is gas mileage, right? You know, how much is the fuel burn in your engine? And all three OEMs take a different approach, but they're getting to the point now where I think what we have on the current design tables is pretty much what we're going to have until we have some significant breakthrough of technology, meaning small compact batteries where you can electrify the engine and not burn fuel, or some configuration of an alternate fuel outside of traditional carbon-based fuels, where you could have enough room for the people and still put the fuel in. The problem with hydrogen is the volume of hydrogen that you need, or the fact that you have to freeze it down and liquefy it to get it into a standard airframe. The economics don't work. You have to have more volume than you have space for passengers, and it doesn't make sense. Not at today's technology. So the engine market's maturing. But it doesn't mean you can't stop scaling it. I mean, GE's about to introduce what they call the GE90 or GE9X, and it's going to go on the 777X. It's going to be the largest fan on a gas turbine engine ever produced. Right. And it's amazing and an incredible machine. And you're going to have two of them on an airplane, and it's going to fly 300 plus people, 15, 16, 17 hours across the water, and with 100% reliability. And you just ask yourself, how does this happen? And it's through dedicated engineers and research scientists and technicians and machinists and laborers in the factory and assemblers who care very much about their industry and what they do. And reliability is the name of the game. Reliability is just as much important as new technology into the engines. All right. When you really think about it, those planes got to stay up there, and they are incredibly engineered pieces of equipment that, short of, I always say short of a nuclear reactor, I don't think there's a better engineered piece of equipment in the world today.
No, and that's for sure. And, it's actually even safer to go on a plane than to drive a car on the highway.
Oh, absolutely.
Talking about nuclear, I wonder, I understand that the risk is there, but, we have nuclear submarines and they can go underwater, I think it's for like 10, 15 years and never come up as far as energy is concerned. Why do you think they haven't deployed anything similar for airplanes?
From a nuclear perspective?
Yeah.
They tried back in the 50s.
Oh, they did?
They did. I happen to work at a facility that Pratt & Whitney currently owns in Middletown, Connecticut. It is not doing, so I'm not misquoted across the internet and wherever else this is heard. I'm not misquoted as Pratt owns a nuclear aircraft engine facility. But there was some experimentation back in the 50s to have a nuclear powered bomber that would never land, that would just circle. And there were people working on it for a period of time. I am not versed in the history very well. I just know one of the Pratt facilities down in Middletown, Connecticut, at one point in time was part of that research project of trying to develop that. I don't think it lasted very long. I think people realized there's one thing about a nuclear reactor underwater, and if something bad happens, God bless the crew, but it just sinks to the bottom of the floor. If you have a nuclear reactor flying above your head and you don't necessarily know where it comes down at, that's a problem.
It's a big problem.
Plus, things fatigue differently.
Right.
But yeah, there have been attempts at that, and who knows, there might even still be attempts today that we just don't know about. But I do know it was an active project in the late 50s, early 60s.
You know, back on your bookcase, you have a plane, and I believe that was the fastest military plane that they ever built, right?
Where's this?
On your bookcase, right above.
The SR-71.
Yeah,
As far as we know, the answer to that question is yes. So
right. I actually met the pilot of one of those planes, and he was born 70% of his skin because he was I don't even remember his name, but I got the book signed by him.
So incredible machines, and to think about it, they were built in the late 50s and the early 60s.
Incredible, right?
And you know, the one part about that airplane that I learned over time is because we didn't have the computational science and the computers that we had today, and some of the alloys and the advanced materials, that the plane actually took off with an almost empty gas tank. Do you know why?
Why?
Because if you filled up the gas tank full, this is at least the stories that I've been told over the years as a young engineer, it would leak like a sieve on the ground. That it's designed that it has to heat up, and the skins of the aircraft, so the thermals were right, would heat up and actually expand to the point where it would seal the tanks, so there would be no leaks. So there would be a refueling plane waiting for it as it took off. It never took off with a full load and then did the mission. It would take off fuel full and then take off. And it needed to heat itself up and to seal itself. So it performed at the rate and the pace that it needed to perform. It's an amazing machine.
And the speed was incredible, right?
Still was incredible. You know, there's all kinds of stories out there that there's replacements to it, but nobody knows. No, nobody knows at this point in time.
So, Ron, how did you get into this industry? What were you in high school? What did you want to do with your life?
So, that's an interesting question. So I was always good with numbers. I was always a good mechanical designer, sketcher. I was fascinated by airplanes. I grew up in a small town north of Allentown, Pennsylvania, called Whitehall, Pennsylvania. 90 miles north of 50, 90 miles north of Philadelphia, 90 miles west of New York City. And I lived across the river from the airport in Allentown. And I was there watching the first 727s and 737s fly over my house in the park and the pool that we used to hang out as kids. And just became fascinated of watching them come in. We right at the point where the wheels would come down and they get the nice glide path across the river to the airport. Between that and watching the Apollo / space shuttle programs as a young boy into my high school, college ages, just picked up the fancy that I wanted to do something that flew. And it's just stuck with me ever since. Over my years, I've been privileged to lead great organizations, different ones, with a lot of great people. Occasionally, it would have a small industrial something went along with it. I had one that had small machine tools. I have one today that's kind of an anti-locking, although it's aerospace related, anti-locking technology in the fastener area. Great industries, good people, just wasn't as sexy to me as something that flies. Okay, my wife thinks I'm crazy. I'm still the guy who will stop driving along an airport to pull over and watch a plane. All right, it's just a gorgeous sight to me, or takeoff. So.
Yeah, it is incredible. I'm also in love with planes since I was a little kid. My brother-in-law was an airplane pilot when he was dating my sister. So he will take me on the weekends on his little Cessna, and we'll go through the pine trees until this river broke into the ocean.
Yeah.
You would imagine the impact that it had in my life, right? Only the two of us flying this thing. And it's like, since then, I've been fascinated about flights and planes.
And it's such a diversity of an industry. I have spent most of my life supporting some type of commercial aspect of propulsion engines, or military, right? Fighters, transports. I did support helicopters in a previous job doing all the rotor heads. But, you know, last week I had the privilege of being in Paris at the Paris Air Show. And the gambit of product that flies is quite amazing. I mean, we all think big commercial airliners, 747s. We all think fighters, F-35s and stuff like that. But when you look at the transport planes that are hauling stuff, you look at the small trainers, you look at general aviation aircraft, business aircraft, Gulfstreams that take 15, 20 people halfway across the world without refueling. General aviation with pistons, and people will just hop between airports traveling like it's some mode of car transportation. The amount of variety of things that are actually in the air is incredibly impressive. And the world's been pushing for the last 10 years. I still think we're on the cusp of air taxis, right? We'll be able to go from point A to point B in some kind of vertical flight machine, cheaply, reliably, go from my office down to Detroit airport instead of fighting the traffic down the highways. It's an amazing industry that allows and it brings the little boy or girl in you out to sit here and think, wow, that's kind of against natural physics of the world. And I have a piece of it. And there's all kinds of different applications that I could satisfy my 50, 60, 70 years on this earth to get enjoyment out of. And that's what really draws me every day, is the fascination of the little kid in you that says, how does that work? And how does that actually make that happen?
Beautiful. Yeah. Regarding the air taxis, I am surprised they are not here yet. I remember back in 2000, there were several startups that they were playing with drones, where the actual drone will be the air taxi and it will be self-driven. So you will get it at a base station, like at the top of a high-rise building or something like that, and then will drop you off somewhere else.
Yeah, like everything else in the world, we need regulation, we need quality control.
Right.
The one thing about this industry, and we already talked about it, is the regulation and the reliability. Anything that's a late comer of technology into this space is going to have to prove the reliability out of the box.
Yeah.
We as a society do not have tolerances for air taxis falling out of the sky like airplanes did in the 19 teens and 20s, right? Mm-hmm. Or look, as a kid in the 60s and the 70s, I can remember with, maybe 1/20th of the number of airplanes flying around the world, the frequency of airline mishaps, right? Today, and hopefully we get none, but today you get one every 2 or 3 years and you say, oh my God.
What happened?
What happens, right? You get into air taxis and you have to have that redundancy and the liability built in there. Then the other question is now you're putting more things in airspace and people need to know where everything is. There are no roads defined up there. There's no, right? You got to make sure somebody's keeping track where everything is flying. Air traffic control is a big deal. There's a lot of problems yet to be solved. It's a lot of opportunity there for people to make some money in the future of figuring out how these industries will mature. But the tolerance of non-success is far less today in an industry like this than what was when it was in its early infancy. And that's, I think, is the change. No one's willing to experiment to the point where people get hurt.
Right.
Which is right. By the way, which is the right thing to do. It's not. Yeah. So
it's the right thing to do for sure. I am amazed that if you look at history, like when humankind invented the plane, it's been what, 150 years or something like that?
Probably, I think the first flight with the Wright brothers, 1903, 1904, somewhere in that flight, maybe 1905. So we're probably about 120 years into flight.
So,
and think about what we've done in 120 years, from somebody who's never flown other than a balloon prior to that, to putting on an A380 over 500 people in the air, an SR-71 back over my shoulder there, who was quoted as doing something greater than Mach 3. We put people on the moon. We have orbiting space stations. All right. We do all of this, and we take our feet off the ground, through some kind of aerodynamic precision, and we bring everybody home safely to 99.999999, how many decimal points you want to take that out to. It's an amazing and a wonderful industry that's where you have to appreciate the engineering, right? And just believe it is incredibly oriented to success, right? There's no failure in this business. And that's the attitude you have to have when you take a career down this path. My job is to make sure things don't fail. And doesn't matter which application you pick, helicopters, rockets, satellites, airplanes, commercial, military, transports, hauling stuff, helicopters. I mean, I'm always amazed when I see a helicopter, and I'm still amazed how a helicopter flies. And we don't have time to go into that today. But watch a helicopter pull an Abrams tank underneath it, right? Moving it across the battlefield. I mean, to think that we could defy physics, something not only stays in the air, but picks up something, how many tons, thousands of tons does this thing weigh, and carry it for miles across a battlefield in support of a mission or some kind of result, or logging or life support, rescue, right? I could take something that looks like it's defying physics and drop it into a forest and save people, or on a fire, or out on oil platforms, wherever you're going. The mobility that this type of industry is provided is incredible.
It's fascinating, you know, and even for like single pilot engines, you know, I was looking into the Cirrus Vision jet. It's a single turbine,
Yep.
probably the smallest private jet that you can get, but you know, you can sit comfortably with 5 people, and a single pilot can fly it, and it's you know, and it's incredible, right?
Well, you have the Honda jet, right? That's the real small commercial one right now. Excellent product, GE powered,
Right.
very well put together. I'm trying to remember the one that was out of Arizona or out of New Mexico, Eclipse. I think that might have been the one you're talking about. They've kind of come and gone a little bit. Couldn't quite get the economics right. Look, in the end, economics is the mother of all invention. You know, as much as I tell young engineers, it's not just can you make it, but can you make it and sell it where it becomes sustainable
Right.
is key. And not all young engineers, probably including myself, really understood that when you get into the industry, right? There's lots of things that can be invented. The question is, are there lots of things that can be invented that humankind actually wants, needs, and is willing to pay for? And that's a big deal. That is a very big deal.
You know, a good example of that is a few years ago, they came up with this sports light engine jet. No, it's not a jet, it's just an airplane, but it's called the Icon A5.
Okay.
And I really wanted to get one of those things. It was amazing because it lands on sea. So it's hybrid, right? It lands on sea or lands on a normal, you know, track. But it was, you know, they had an angle of attack. It was designed by an F-15 pilot. So the plane looked amazing. And you only needed a sports license, you know. But now they don't make them anymore. I think the company went bankrupt.
Yeah.
To your point, right?
Yeah, you have to be able to sustain the economics, right? The Eclipse jet, same thing. Everybody thought they'd have one in their driveway by now. It doesn't quite make sense. It's always neat to be the first one to do something, right? But it's even better to be the ones who figure out how the next million people could be behind the first one, and you could sustain an industry behind it. So, you know, we talked earlier about what's next in the gas turbine land for commercial airframes. There's lots of creative ideas on how to propulse an airplane across the sky. The question is, what makes the most economic sense in a mature industry with the reliability that you need is actually a harder physics problem than just solving the physics problem with a flight right up front right now.
So incredible. It's fascinating. Ron, out of your entire career, what has been some of the toughest problems you had to face, and how did you overcome it?
Surprisingly, they're not technically generated. They're usually human generated. I have had the privilege to service this industry for almost 4 decades now, which is crazy for me to say. Pratt Whitney was my first job out of college. I worked there for 17 years. I say this with great pride. They trained me. They saw things in me that I didn't even know. But they also taught me, and I learned over time, you have to be true to the problem that's in front of you.
Mm-hmm.
A lot of the toughest problems that I had to resolve, and they were usually business-oriented problems, whether it be manufacturing facilities or there have been times over the years, technical facilities. It's usually because somebody oversold or undersold a position around a product or an output that was not realistic, but usually did it for some economically selfish reasons and couldn't come with the grips of reality. I'm a believer in just, these are the facts and we're going to deal with the facts. And if it's not politically correct, I'm probably not the person you want solving your problems. I think we live in a world where trying to be politically correct is more important than fixing problems sometimes. And so when I look at my career and the history, I've had the biggest success when I've been able to take a group of people, kind of wipe away the politics of the moment, put them on technical, being it could be monetary, it could be operational, it could be actual technology of the product, and solve it as a team and as a group of leaders who are willing to embrace a challenge focused on what the truth is telling them, whether that's technical physics, whether that's monetary output, whether that's human capability, and solve it in a way where you get to the right answer and then be able to deliver that answer to whoever the owners or the customers are, educate them to why you did what you had to go do and why they have to live with the result that they have. So long answer is saying the best problems I've ever solved are the ones that most people run away from because they're afraid to tell the truth about what's really happening. And there's sadly more of those cases around than most people want to admit to.
And it only sets us back, right? Like, I'm a man of faith, so my moral values come from the Bible. And if you follow the truth and if you follow morality and common sense, you will solve the problem. But the problem is that people will, when you do that, a lot of people get upset.
So here's, look, I've been guided and taught by some great leaders across multiple different companies, not just Pratt Whitney. And I kind of guided my kids this way too. It's not that people aren't trying to be their best. It's people get afraid, particularly the older they get. They become more ingrained with a lifestyle, a livelihood, a set of economics, and they're afraid to lose it. And when you're afraid to lose, you do things that aren't necessarily in the best interests of the problem that you've been given at hand. And this has been my experience. Okay. I've told my children every time I've taken a promotion, every time I've gotten a new job, every time I've taken over a new company where we got to go fix something, I'm betting that I could do this. And I have to go in there with the mindset that I might lose everything that I've done up until that point in time. Reputation, money, monetary status, whatever the right term is.
Right.
With the understanding that if I'm successful, we'll be better off on the out end. All right. Most people are afraid to engage conflict at the risk of personal loss. Most people are afraid to engage some of the truth at risk of personal loss. Most people are afraid to engage in the very hard problems because they don't want to put themselves in somehow harm's way. And usually the biggest problems are causes of people running away from problems or not recognizing a problem for what it actually is, or truthfully assessing the problem for what it actually done because it's normally politically incorrect. I got to spend more money than I thought. I got to go hire more people than I thought. Or I have to maybe get rid of some people that I didn't think were doing the right thing. Or I have to re-engineer this and start all over again. or the reason this isn't working is because we did this wrong back then. And you have to bring that conversation and argument forward. You know, one thing I've discovered about leadership isn't easy, but it starts with your own personal moral fortitude. And once you build off of that and understand that as you're taking on these challenges, as you look to what you're doing, you have to leave a legacy behind that says we have to do it right all the time. Not just the first time, not just when it's politically correct, not just when it's financially correct. We have to stand by our morals and our fortitudes and on our basic groundings all the time. And if you do that, you could take on some great problems in this world. And you have to be a good communicator on why you're doing it too.
Right.
All right. You know, somewhere in this conversation, we talked about me being a shy, introverted engineer when I first took that job. And that's the truth. But I've grown because I wanted to solve problems. And the only way you're going to really solve the problems and do what I just said about fortitude and doing it right is you also have to communicate in a way where you teach and educate people why the right thing is the right thing. Otherwise, you just have more politics and more interpretations. So it's nothing. I don't think I'm saying anything that's earth shattering. People just have to keep their own moral fortitude. They got to keep their eye on what they're trying to do. They have to make sure they do it in a way where it's equally distributable to the point where we're not playing favorites or you're not siding with anything and you're doing what's in the best interest of the problem. Might not always be in the best interest of the company, but it's in the best interest of the problem. And that's really what separates a lot of good leaders from great leaders is sometimes we're a little too something centric and not willing to expand our horizons, understand the problem might be bigger than the viewpoint you have.
It's cool. So true. So much wisdom. Thank you so much for that, Ron. And people are not willing to do what it takes to be in the position that you are, because it takes courage and willing to risk it, right? Taking those measured risks in order to solve the problems that are in front of you. And that's why you have the opportunity and the privilege to lead such a big company, right? Not everybody is set up for to do that.
I've always believed that somebody doesn't like what I'm doing because I'm doing it right, then I'll go do something else for someone else who has the same vision and fortitude that I have.
Right.
And the other thing I always say too is people know you have to play to win. And I know there's books, I think, titled this. You have to play to win. If you're playing not to lose, you're going to lose every time.
Yeah.
If you're playing to win, you at least got a 50-50 shot of winning.
Yeah.
And once you win the first time and people see how you did it without playing politics, without playing favorites, we're really focusing on the problem at hand. The world has a way of finding you to the point where you get those next challenges and the next challenges and the next challenges, whether it's internal in one big company, like I did for the first 17 years at Pratt, or like I've done for the last 23 years, which is, you know, finding different companies that had different needs and me jumping in and doing what I like to do, which is build teams, solve problems, kind of take the BS out of the equation. All right. And really get down to the root cause of the problem. And then once you get it fixed and it's ready to run on a day-to-day basis, I like the next big problem and let somebody come in here and run the day-to-day here. I mean, but you got to be cut out for doing that kind of stuff too. So.
But you know, it's because of people like you and that mentality that this great industry is being built and it's so reliable, so that people take for granted when they jump into a tube that takes them to the other side of the world in 10 hours.
Look, there are, I say this with utmost respect, there are far, far, far smarter people in this industry who understand the technology far better than I do. I have a good engineer's perspective of how things work. I'm not the perfectionist of how things work. But you're right. If you don't have that drive, if you don't have that dedication to making sure it's right, you're just bringing trouble upon yourself and the people around you and the company you work for and the customers who you sell to.
Right.
If you don't have that perspective that we're going to do what's right all the time.
That's fantastic, Ron. Almost more than 40 minutes have gone by. I told you half an hour, and look, I took 15 more minutes out of your time. Sorry about that.
I look, it's the end of the day, so I'm good. I'm still on Paris / Derby, England time, so I'm still trying to catch up. So
Good stuff, Ron. Thank you so much. I'll ask you one last question before we finish the podcast. If you had access to a billboard in front of the busiest highway on earth, what would you write on it?
believe in yourself.
Believe in yourself.
Believe in
Have
yourself.
courage. And to have courage, you need to believe that what you're doing is right. Isn't it?
Absolutely. Absolutely. And I might even been like this in the early ages. Everybody wants some kind of approval or some kind of acknowledgement. But I always tell people the person you have to answer to most in the morning at any point in time is the person you see in the mirror in the morning.
Right.
And if you believe in the person that you see in the mirror in the morning, you could take on just about any problem. If you believe you have the talents and the skills to solve the problem in front of you, do not second guess yourself. And oh, by the way, I'm doing things today that I never dreamed of the day I graduated high school and college. All right. But the world put those opportunities in front of me. And somewhere inside of me, I had the idea that I can do it. And I believed in myself and we'll figure it out. Not always alone. You need a good team around you. Okay. And you need good technical experts in certain aspects. But it starts with you believing in yourself, never second guessing yourself, never doubt that you could do bigger and better things than you've done before. And in some ways, doing what I said earlier, every time you take on a new challenge, you got to recognize you're betting that what you did up until that point in time, you could lose. But you got to believe in yourself that you're going to do it, you're going to win, and you'll succeed. And life will be better on the back end.
Fantastic. It's incredible. Thank you so much, Ron, for your time, for your wisdom. If people like to follow you, are you on LinkedIn?
I am on LinkedIn. You could find me on LinkedIn. Yes.
Fantastic. Thank you so much, Ron. God bless you. And let's keep making this industry a better place all the time.
Dave, it took a long time to get this together, but it was fun. I enjoyed it. Hopefully this helped somebody somewhere along the way, not just an old guy ranting, but look, it's life is life is special, right? I always tell people you get 80 good years on this earth if you're lucky. The first 20, you don't have much choice on. The last 20, you want to relax and have fun. What you do in that middle 40, you got to be proud of, you got to be confident in. And when you're done with it, you got to say, I did my best. And look, helping other people listening to these conversations, helping you with your stuff is all stuff I take great pride in right now. So thank you for the opportunity. Hopefully this was somewhat good for folks who listen to the podcast and listen to what you do. And if I could ever help you again, just pick up the phone and call. So
fantastic, Ron. Thank you so much. Like I said, God bless you. You have already blessed me. So this is already worth it. And, I have this amazing privilege of receiving all the knowledge firsthand myself. But I know many, many people will actually get a lot out of this episode. So thank you so much.
Well, no, thank you. And thank you for the opportunity. Take care, my friend. Talk soon.
Wonderful rest of the week. Bye.
Bye.
That's all for today's episode of the Break Free Podcast. Head on over to iTunes and subscribe to the show. Starting your own business can be tough, but it doesn't have to be. Visit davidmansilla.com to pick up a copy of the #1 international best-selling book, Breaking Out of Corporate Jail. Expand what you consider to be possible and reach your full potential. And join us on the next episode.